Welcome to the Unlocked Podcast, a podcast where we decode human performance one gene at a time. I'm Tony. And this series isn't just about science, it's about unlocking the hidden power you carry in your biology so you can train smarter, live longer, and activate what most people think is fixed. We're going to talk about genes, healing, mental clarity, recovery, and even where science and soul start to meet. But we're starting with the foundation. Because most people don't know what DNA really is or how much control they actually have. Welcome back, everybody. Part 2, okay? As always, thank you for listening, and I hope that you're ready to dive in. Part 1 gave you the main correction. MTHFR is one enzyme inside folate biology, not a headline that explains your whole life. Folate is vitamin B9, and your cells use it for foundational jobs like building DNA and making new red blood cells. So when MTHFR shows up on a report, the useful move is to shift from label to function. People get stuck staring at the gene. A better question is whether the pathway is running smoothly in you. The signal most people hear first is homocysteine. Homocysteine is an intermediate in the methionine cycle. Again, an intermediate means it's supposed to move through the loop like a relay baton, not pile up at the handoff. In part 1, we talked about how observational research found that higher homocysteine tended to travel with higher cardiovascular risk. Travel with is the key phrase. That kind of study can show association, two things moving together, but it cannot prove that one causes the other. That's why the next step in research was obvious. If homocysteine is part of the risk story, lowering it should lower outcomes people care about. Large randomized controlled trials, tested that idea. Randomized controlled trial means people are assigned by chance to an intervention or a control, which helps separate cause from coincidence. In trials like HOPE-2 and NORVIT, the interventions lowered homocysteine, but the outcomes people actually care about were not consistently improved across trials. This is important because that result teaches a useful mindset. The dashboard light can be real, and the light can be related to real risk, but turning off the light is not always the same thing as fixing the engine, as I made that reference prior. So if you choose to use labs, the goal is not to chase one number. The goal is to understand the picture the labs give you. Now, we went over this a dozen times, so I want you to really pay attention to that because sometimes we can start telling ourselves a particular story. And if we adopt that story, it can cause a ton of distress. So let's move on. Serum B12 is a vitamin. B12 is measured in the liquid portion of your blood. If blood were a smoothie, the liquid portion is the part you could pour, and the cells are the thicker pieces floating inside of it. Serum tells you what is circulating. Folate can show up as serum folate or RBC folate. RBC means red blood cell. Red blood cells are the oxygen carriers in your bloodstream, and they live for about 120 days, roughly 4 months. So RBC folate is folate inside those cells, which tends to reflect longer-term status, more like an average over time than a single meal. Serum folate is folate measured in the liquid portion, and it can reflect more recent intake. There's a nuance worth holding without overcomplicating it. Some clinical chemistry guidance argues serum folate is often the more practical test in many settings, partly because true folate deficiency is less common in fortified food environments and partly because of testing consideration. That's one reason the labs are best interpreted with a clinician who knows the full context rather than treat it like a fortune cookie. Once you understand what the tests mean, the next question is always cool. What do I eat and how much? That's where the micrograms and kilograms sneak into the conversation. I'm going to translate those into kitchen and bodyweight terms so it's actually usable. A microgram is 1/1,000,000th of a gram. It's tiny, and that's normal because vitamins and minerals do their job in small amounts. You're not supposed to picture a microgram as a spoonful. You're supposed to picture the food that reliably contains it. So when you hear that adults need 400 micrograms of dietary folate equivalents per day, and pregnancy needs about 600 micrograms, the point isn't counting micrograms with your eyes. The point is choosing patterns that cover folate without turning eating into math. So here's an example of 2 day-to-day folate pictures that feel like normal life. Picture 1. Let's imagine a lunch bowl with 1 cup of lentils and a big handful of leafy greens. The cup is a real measuring cup. Lentils are folate dense, greens are the leaf in folate, remember folium, literally where the name came from. Picture 2. A dinner plate with beans on the side and cooked greens on the plate. It's not really glamorous, but it keeps the foundation, or more so your foundation, stable. B12 is a little different. Adults need about 2.4 micrograms per day. Same rule. You're not measuring micrograms in the kitchen. You're choosing reliable sources. But if you do want to purchase a scale, I encourage it. If you really have some goals that you want to hit or numbers, go ahead. My thing is also be careful and just make sure you're doing it in a safe, healthy, conscious type of way, if that makes sense. B12 is naturally found in animal foods like meat, fish, eggs, and dairy. It can also show up in fortified foods, meaning the nutrient was added to the food, like some plant milks. If someone is vegetarian or vegan, B12 becomes a planning problem just because deficiency can creep up slowly, which is why consistency matters more than intention, right? You can intend to do something, but you want to consistently eat that because you need the nutrients, right? There's no other way to say it. If folate is the steady background music, I want you to look at it like this. B12 is the drummer. You don't notice it until the rhythm drops out. That's not something you want to happen. I'm not trying to, have you be afraid. Just educate you, right? Protein is another lever people underestimate because it gets framed as only a gym thing. Protein is made of amino acids. Amino acids are building blocks for tissue repair, and they also feed into neurotransmitter chemistry indirectly. So that's why starting your day with protein is super important in terms of brain health and just functionality. Now let's address kilograms. Kilograms show up here because protein targets in research are often written per kilogram of body weight. A kilogram is about 2.2 pounds, so if you weigh 165 pounds, you're about 75 kilograms. You convert once you're done. A practical performance target supported by resistance training meta-analysis is around 1.6 grams of protein per kilogram per day for many people. I say a little bit more would always benefit you, just in case. That's just my take. So then at this point, it becomes your meals and you're not really focused on the math. If you eat 3 meals, an anchor is around 35 to 45 grams of protein per meal. I typically do about 60, but just let's say with these numbers, if you add a snack, the per meal target comes down. So what 40 grams looks like in real life, chicken or turkey, about 6 ounces cooked. Fish, about 6 ounces, same thing. Greek yogurt, about 1.5 to 2 cups of high protein Greek yogurt. I like to put in my pancakes and my smoothies. Eggs plus extra, right? 4 eggs get you around 24 grams. So pairing it with a Greek yogurt, cottage cheese, or protein shake closes the gap. I always tell all my clients, make sure you're doing the protein shake in the morning. You can put it in your coffee. Nice little side thing of yogurt and some berries. Never hurt. If you're more plant-based, the big bowl of lentils plus tofu or edamame, because a plant protein often needs pairing to reach the same totals. This isn't about chasing perfection. It's about steady building blocks so you're not running your day on fumes and then blaming your genes. So once the nutrition and lab language is clear, the brain layer stops feeling mystical and starts feeling like biology again. So neurotransmitters are chemical messengers that the brain uses for communication. Dopamine is involved in motivation and reward signaling. Norepinephrine is involved in alertness and attention, and serotonin is involved in mood regulation. People hear methylation and assume it's a master switch for neurotransmitters, but methylation is a chemical transfer where a small methyl group is attached to another molecule. We've went over this again, but just for some recap, it's in the body. It can affect how molecules behave, including how some genes are expressed. So gene expression means how actively your gene is used to make protein. That's what this podcast is all about. DNA methylation tends to behave more like a dimmer than a light switch. Really important picture. Why did I go over neurotransmitters? Why did I go over epinephrine, norepinephrine, dopamine? Because this is where ADHD fits in. ADHD is a neurodevelopmental condition, and it's polygenic. I found out that I had ADHD at an older age, around 28, which was very interesting, yet kind of, I knew it moment, right? So polygenic, I'll get right back to it. Polygenic means many genes contribute small effects rather than one gene determining the outcome. MTHR is not the ADHD gene. The research question people ask is whether MTHFR variant contributes to ADHD risk or symptom severity in a meaningful way. The clean answer is that any contribution, if present, is not a single lever. Again, if present, the clean answer is it's any contribution is not a single lever. It would be one small part of a bigger landscape that includes sleep, stress, nutrition, and overall brain chemistry. So ADHD stands as an applied example, not the center of gravity. When the system has less margin, symptoms can feel louder. That's different from saying a variant causes a disorder. A few factors often carry more leverage, and they're also easier to measure and improve. Let's take a look at iron and ferritin. Ferritin is a blood marker that roughly reflects iron storage. Some meta-analytic work suggests children with ADHD on average have lower ferritin than controls, though findings are not uniform, and it does not mean low ferritin causes ADHD in every case. Iron is also relevant because iron is used in enzymes involved in dopamine synthesis. That's one reason clinicians sometimes look at ferritin when attention, fatigue, or restless sleep is part of the picture. Here are some iron-rich foods to make sure we're helping the brain do what it needs to do, especially if you have ADHD or ADHD-like symptoms. Red meat, shellfish like oysters and clams, lentils, beans, pumpkin seeds, and spinach. If you are more going for a plant-based diet or plant-based eating style or lifestyle, plant-based iron is absorbed less efficiently than heme. Iron from meat, or it might be heme, please guys correct me. Pairing plant iron with vitamin C can enhance absorption. Vitamin C is in citrus, strawberries, bell peppers. Think of vitamin C like a friend who speaks the language. The iron tends to get through the door more easily, right? You know French, you got the bouncer who knows French. The bouncer is going to say, Mademoiselle, I don't know if that's French, and then let you in. Then we have our omega-3s, right? Omega-3s are fats. The two most studied for brain are EPA and DHA. In the ADHD literature, some meta-analysis suggests small symptom improvements, and other analysis show mixed results depending on the dose, duration, and study design. So I treat omega-3 as a potential support, not really a promise. Although, again, I do make sure my son is getting ample amount of those in addition to rest. So we're going to look at some more food sources in terms of omega-3 fats. Fatty fish like salmon, sardines, herring. If someone does not eat fish, you can always go for algae-based DHA. That's another option. If we're looking for the dosage, for general health, many sources discuss 250 to 500 milligrams per day of combined EPA and DHA as a common range. In ADHD trials, higher EPA containing formulas are sometimes associated with better effects in some meta-analysis, though effects remain modest. So it doesn't hurt to get that food in. For me, I see it as a plus and positive. And I mentioned sleep before, so we can get into the sleep environment and also your environment in terms of stress. So environmental stress does not have to mean something dramatic. It can mean chronic uncertainty, inconsistent sleep, high conflict environments, financial pressure, doom scrolling late at night, or a schedule that never lets the nervous system settle. A lot of what people are dealing with day to day. If stress is a volume knob on the whole system, sleep is the power supply. So you can have the best supplements in the world, and if the power supply is unstable, the signal keeps cutting out, if that makes sense. Now let's look at some protocols. Again, right now I'm salivating a lot, so bear with me. So let's look at the MTHFR pathway support plan and practical things in a detailed way that you could use. So you want to decide, what are you actually checking? If you have a DNA report that flags MTHFR and you want to understand whether it is functionally relevant, focus on the signals. So homocysteine, B12, the status of that, and folate, the status of that. That basic cluster keeps you from falling into the one gene trap. You're not trying to build a story off of a single variant. You're checking whether the pathway looks supported. If someone's feeling fine and they just want context, that cluster may be enough. On the other hand, if someone's feeling off, they're fatigued, you have brain fog, low mood, your attention feels scattered, it can be helpful to widen the picture with a clinician so you're not guessing. This is where labs like ferritin and iron studies come in, because ferritin is a marker of iron storage. Vitamin D can also be worth checking if it hasn't been looked at in a while. A basic metabolic panel and a CBC can help rule out obvious stuff, because sometimes what feels like brain is actually sleep debt, anemia, thyroid adjacent patterns, or recovery problems showing up as symptoms. Then the food part gets super simple. You're not trying to calculate your life. We don't want too much math. You're trying to build a repeatable base. Okay, so start with folate for 2 weeks, 1 folate anchor every day. A folate anchor can be 1 cup of cooked lentils. I went over this before. 2 big handfuls of leafy greens, salad. You can cook it if you like. Try to do more of a steam, keep those nutrients. If you want to round it out, foods like asparagus, broccoli, and avocado fit well as add-ons. If you want a simple day, you can actually repeat. Lunch can be greens plus a couple lentils. Dinner can be beans on the side with cooked greens. Nothing fancy. Just try to keep it consistent. Then B12 gets handled based on how you eat. Right, so if you eat animal foods, you're looking for a B12 source most days. Correction, eggs, dairy, fish, meat. If you don't eat animal foods, B12 needs a plan. So fortified foods can help. Supplements are often used too, but dosing should be discussed with a clinician, especially if there are absorption issues or neurologic symptoms. Then you lock in protein, because protein is one of the easiest ways to stabilize energy, appetite, and your recovery. You convert body weight once. Pounds divided by 2.2 gives you kilograms. Again, pounds divided by 2.2 gives you your kilograms. So if someone is 165 pounds, like the example I used before, that's about 75 kilograms. For people who lift, a usual training target is about 1.6 grams per kilogram per day, which puts that person around 120 grams of protein per day. I typically eat more. Then it becomes meals. Again, not math. 3 meals around 40 grams each, 4 meals around 30 grams each, and then you'll be giving your body enough building blocks to recover without needing a perfect day. For iron, think a few times per week. If you eat meat or shellfish, 1 serving in that week helps. If you're plant-based, lentil, beans, seeds, spinach, they all work, and vitamin C with the meal improves its absorption. For omega-3s, twice a week is a clean starting point. Fatty fish, if you can eat it, and if you don't, algae, DHA is a conversation to have with your clinician. Now, the nervous system piece. If attention feels worse when your sleep is poor, meals are skipped, or stress is high, this isn't the gene talking. That's the system losing its stability. ADHD stays in the episode as a symptom layer, not as the headline. So, the first line of intervention is always going to be stability. A 2-week stability challenge will look like this. Same wake up time most days, protein at breakfast, even if it's a simple one. 1 folate anchor daily, phone away, right? 45 minutes before sleep. Then you're going to reassess how attention feels. Not in a dramatic way, just honestly, did that day feel steadier for you? Did your patience improve? Did focus come back online a little bit more? So to close out, if you take one thing from part 2, is that you can respect genetics without letting it narrate your whole life. I want you to use it as a context. Check your connected signals and build the foundations that make the whole system quieter and more resilient. And the way that we always end every single podcast, I want you to remember, your biology listens. Live like it.